Topic 5-5. This can be referenced in our Holt textbook, Chapter 6, Section 1, pages 384 through 385. Actually, I think it goes through 388. I wanted to start this one out using my iPhone because we're dealing with more angles of polygons that deal with exterior and interior. And I wanted to show an example of a decagon that is actually the aperture of a camera that we use, a lot of us use every day on our phones. So if you'll watch closely, as I push the camera button, well, actually it'll show that if you saw it quickly. I'm going to do it one more time. If I were to take a picture, notice the camera. Let's see if I can take it. I don't know if I'll do it one more time. See the camera, and it goes in and then out. This was on page 385 of our textbook when they showed the sides of a aperture of a camera forming 10 blades that go in and then out to open up the lens. And we learned that all the exterior angles, the ones that form on the extensions to the exterior of a polygon, form 360 no matter what size the polygon is. So I thought I'd show an example using my camera phone, and if you every time you see that, you can think about the exterior angles of polygons. So let's go over some examples. So we're going to recall that to find the sum of interior angles, remember that we're looking for the total sum of interiors is the 180 times the number of sides minus 2, and the sum of the exterior angles is always 360. Oops. To find the measure of each interior and angle of a regular polygon, I'm not going to highlight or underline that. Remember, regular meaning the exact same number of sides and the exact angle measurements for every angle in the polygon. So here's some examples of that. If you've got exterior angles of regular polygons, I put down 4 examples here. A pentagon, a triangle, a heptagon, which is 7 sides, and a decagon, like our camera aperture. So look at the pentagon. If you were going to ask for the sum, of course, all the sums of every one of them is always going to be 360. To get the measure of each angle, only if it's a regular polygon, which means all of these side lengths, segments are exactly the same, and all the interior angles would measure the same. Therefore, if 360 was divided by 5, you would be able to find the sum of each interior angle. So 360 divided by 5 is 72. So what that means is that this angle right here, use a different color, this angle measurement right here is going to be 72 degrees. This angle here, 72 degrees. All the way around, these marked angles would all equal the exact same, and if added together they would equal the 360. So this is kind of where we can get the measure of a triangle. If you needed to know the measure of this angle, and this angle individually, take 360 and divide it by 3 sides. And so each of this outside measured angle is going to be 120. And we already knew that an equilateral triangle also is equal angular. In this linear pair, this would be 60, this would be 60, and this would be 60. So that proves that the exterior angles would all be 120. I'll go back and put the answer here. Okay, and so on. 360 divided by 7 and 360 divided by 10. That would give you these exterior measures of the exterior angles. So if these notes help kind of see the markings of the extensions forming a linear pair with the vertex, this is always going to total 360 degrees. Okay, let's go a couple more examples. A heptagon, again, with 7 sides. So if you needed the sum of the interior angles, you're taking the formula where you take the number of sides minus 2 times 180, you would get 900. For the sum of the measures of the exterior angles, always 360. Okay, for a 13-sided polygon, we're getting larger. The largest one I drew on the examples prior was 10, but as you get larger and larger, the sum of your interior angles is going to be 1980. And again, if we're just dealing with interior angles and wanted to know each interior angle, you would take that same formula that you got the answer 1980 and divide it by the number of sides. So the number of sides was 13. Fill that in, divide, you would get a fraction 152 and 4/13. Or you could leave it in a decimal form too. The sum of the measures of the exterior angles is always 360, and if you wanted to find the sum of each exterior angle, then you would take 360 and divide it by the number of sides, which was 13. Please make note, and I'll highlight this again, this finding each measure has to only be for an exterior if it's regular. It has to be regular. So doing that, the answer is 27 and 9/13. Pause it if you need to copy the rest of that, but let's move on. Finding the number of regular polygons for each exterior angle of a measure of 8. Okay, well, they've already given you that the measure is 8, and they want the exterior, which is this formula. So again, we don't want the denominator to go away, so we're going to multiply by n on both sides. A lot of times I show that in a different color. If these are my multiplying by n on both sides, then these n's go away. Therefore, 8n is equal to 360 divided by 8, and you get 45. So number of sides, that would be a huge polygon with lots of sides, but notice that the degree measure was quite small. An 8-degree measure, if you'll think about angle measures, is only going to be about right there, that tiny little angle. So if you kind of drew an example of what an 8 degrees, actually that's probably a little too much. It's probably more like that. A very tiny exterior angle measurement for that one. I'll have to erase that later. Okay, the example for this one, we're looking for the outside exterior angle, and we were only given that this is a box, so we know that's a 90-degree angle. So adding 90 and 25 would get you 115. The value of x is 115, and the angle measurement is also 115. Last example. Again, you count up the number of sides we have. This is not a regular polygon, but it is a 6-sided figure. So 6 minus 2 is 4. 4 times 180 would give us the sum of 720 degrees. But if you needed to know what this would be, then you're taking this one, all these, and adding them up to get 571. If 571 degrees is the measure of these 5 added together, you would subtract that from the 720. The 720 subtract the 571 is going to leave you with 149 degrees. So that's going to leave you the 149 degrees. So this will help you with the last section of Unit 5, 5-5.